Technical session. This is the workshop on the biogas and discussion on the role of technology advancement in bioenergy, including biohydrogen. Please put your hands together as I invite the distinguished panelist of the session onto the stage. I invite onto the stage Technical Director Weber NTech, Mr. Antti Grams. Please put your hands together as we welcome the panelist onto the stage. Our first speaker is the Technical Director Weber NTech, Mr. Antti Grams. Warm welcome to you. May I also invite onto the stage founder, Sanbhogya our Energy, Mr. Anand Kavare. Very warm welcome to Mr. Anand Kavare. Sir, kindly join us onto the stage. I also invite onto the stage Director, Biomembrane Systems India Private Limited, Mr. Prantik Sinha. Very warm welcome to you, Mr. Sinha. We're now being joined by the CTO Cube Renewables India, Dr. G.P. Govil. Very warm welcome to Dr. G.P. Govil. We're also very honored to have with us the Deputy General Manager Design and Development Kirloskar Pneumatics, Mr. Praveen Nilekar. We welcome Mr. Praveen Nilekar. And now we request the Area Sales Manager Suma to kindly join us onto the stage, Mr. Roman Mitrofnau. And kindly put your hands together as I invite on stage the moderator of the session, the Director Operations IBA, Mr. Abhijit Mukherjee. Very warm welcome to you, sir. Ladies and gentlemen, this session will dwell into the role of technological advancements in the application and reach of bioenergy with a specific focus on optimal technology adoption based on prevailing factor. And we will gain some valuable insights into the available knowledge for both small and large-scale biogas plants, real-life case studies which showcase successful projects highlighting the impact of technology-driven initiatives in the bioenergy sector. And also the participants will get to explore the training and incubation programs that support aspiring entrepreneurs and startups in the biogas industry, fostering innovation and growth. Biohydrogen shall be emphasized as an important option in the energy field. With those words, may I request the moderator of the session to kindly take over.
Hello. Yeah. So thanks, Susmita. Thanks for the grand introduction. So good evening, everyone. So my name is Abhijit Mukherjee. I'm the Director of Operations at Indian Biogas Association. And it feels wonderful that after such an exhausting 3 sessions, we are still left with so many participants, right? So, and especially after the lunch, it becomes really difficult to kind of keep yourself active. So many thanks for that. Thanks to the participants, right? So in this particular session, what we are going to do is we will have a mix of discussion as well as presentations. So we have a host of elite panelists along with me, right? So even before I get to my elite panelist and the co-panelist team, let me set the context right here. So means we have been hearing all through the sessions. In the first 2 sessions, we heard more from the macro point, and then in the third session, the previous session, we had technical discussions, right? So means something seems to be quite obvious over here. Means in the last decade or so, if we kind of do a wrapping, there has been tremendous efforts which has been put forth towards the climate change mitigation, both at national and international level. And one thing that is quite obvious in all of this is it is becoming more and more inevitable for all of us to adopt the clean energy or the renewable energy into the overall energy mix. That's quite obvious. There is no other way out of it, right? And within this context, I would like to set forth that means the CBG, particularly the CBG, is one of the lowest hanging fruit. Means if you are looking to kind of ramp up the renewable into the overall energy mix, CBG is of course the lowest hanging fruit. And I say so because the Panchamrit initiative, which has been taken up by India at the global scale, wherein we are looking forward to become a net carbon zero by 2070, right? So that is something which can be attained upon adoption of CBG. And of course, uh, we talk about the self-sustainability, we talk about the Atmanirbhar Bharat, right? So the CBG also has to do a lot with becoming self-sustainable, be it in form of reduction of crude imports, reduction of the fertilizer imports, maybe even in form of, let's say, scientific waste management. So there are various aspects which can be addressed to this CBG or the biogas. So keeping that in mind, means I won't take much time, right? So we have a host of panelists over here. So let me first get to Antig, who is representing Weber and Tech, right? So I believe he has got a presentation to share with us, right? So if you can quickly cite some of your experience, some of the innovations that you have come across, right? So if you can quickly kind of guide us through your presentation on that. Maybe we have 10 minutes of your presentation, right? So please.
So, hello. So you can hear me. Hello, my name is Antin Krams. I'm technical director at Bioenergy, and in the next 10 minutes, I will show you a little bit what we can do with ultrasound, especially in the Indian market, to improve the efficiency of biogas plants. Okay. So I will talk a little bit about our company and explain you a little bit ultrasound technology before I go to the benefits. I think this is most important points. If I have some real references, which is very equal to the Indian market. Weber Entech is a daughter company of Weber Ultrasonic, and Weber Ultrasonic is a leading company in producing ultrasound components, and they are used everywhere in the world in cleaning processes, welding processes, and cutting processes. And we, as the company Weber Entech, use the technology of our mother company to develop the perfect ultrasound technology for the application we see in the market. We use our technology mainly in biogas plant and wastewater treatment plants, but we have applications in the food industry, in the pharmacy, in the chemical industry, and the paper industries too. Today we will talk about the biogas plants, which is our main business, where mostly the target is to increase the gas output so that you earn more money with your biogas plant, and we make our operators able to use difficult treatable substances as Napier grass, for example, or straw. Before I come to the details, I want to show this picture. I know it's not so nice, but you all know how biomass looks like. We are talking about biomass. And on the left side, you see typical biomass from a digester with 13% dry matter, which is using a lot of grass. And you see the problem, you all know the problems when you have substrate like this. It is difficult to steer. You have problems with the agitators and the pumps. And for this, many biogas plants need a solution, and I will show you how you can solve this problem. With our ultrasound technology, we disintegrate the substrate on micrometer scale level. And the physical principle behind the ultrasound technology is cavitation. That means we create cavitation, not the sound itself is disintegrating the substrate, it is the cavitation implosion on micrometer scale level, which destroy the structure of the substrate. For this application, we developed a new design of ultrasound reactor, which is usable at biogas plants very easy because it's a throughput cell and there is no problem with clocking comparing to the traditional technology. It is a cell where on the surface outside we have 24 transducers which are creating a very homogeneous cavitation field that when the substrate comes with big particles from the left side in the reactor, inside the reactor, they get destroyed by the cavitation so that you have small particles at the outside of the reactor. This is a reactor in real life. We have one at our booth. I have seen many of you were already at our booth and have seen this reactor. If you have time later after the session, I can show it to you there. We skip this. So, because we have not so much time. So our machine is always a plug and play machine. consisting of a pump, of a pre-grinder, and in this case 6 ultrasound reactors, a little bit of measurement, pressure sensors, temperature sensors, and for sure there's a PLC controlling everything and controlling the whole process. The installation is quite easy. We only need 2 pipes from the digester. We take the slurry from the digester, treat it, and give it after the treatment directly back to the digester, so that you have the advantages in the digester. So quite easy installation. Back to this picture. So I discussed a lot the last 3 days, and I heard that the Indian market is on the way to use a lot of Napier grass. And with the Napier grass, you get this problem. So you have a lot of fibers, even when you cut it in a good length and have a good feeding with 10 millimeters, which should be done, and you have a good mixing, you still have a very thick material, which is problematic in the digester. And by treating this with ultrasound, we can destroy the structure of the fibers. And the fibers are the problem. It doesn't matter if it is fiber from grass, from Napier, or from straw. The fibers is the problem. It is collecting all the water. It is binding the water. In this picture, you see 13% dry matter. I know every operator, when it heard 13%, oh, that's so dry. But see from the opposite, from the different side, it is 78% of water. So there's a lot of water. Theoretically, it can flow. And with the ultrasound technology, you destroy the fiber on micrometer scale so that it cannot bind the water anymore so good, and that it get more liquid. So at these pictures, you see the same substrate from the same digester before and after treatment, same trimeter content, but in the treated condition, it is much more easy to digest, to get more gas from this more liquid substrate, and you get the problem solved you have in the digester. So go forward. So in average, we reach at our biogas 15% more biogas. We have biogas plants which are running very perfect in Germany. Then we have a not so high increase of 10%, but we have other biogas plants where we can increase the output by 30%. But this is always, as we need to look at the special biogas plants. Yeah, the effects of ultrasound disintegration is that we increase the biogas yield, we decrease the viscosity. These are the main advantages, and it makes possible for you to use grass, straw, or Napier and such difficult substrate with a lot of fibers. And now I have some examples. I think this is very interesting for you to see real plants. This is a solution I would prefer for the export, which is placed in a container. We made this in Denmark. It is a machine with 12 ultrasound reactors, and this is very close to the size you would need in India when you plan to feed 100 tons of Napier grass, which I heard a lot here in the last 3 days. And you can easily place it directly next to the digester, connected to 2 pipes and a power connection. That's it, and it runs. And because I think the time is nearly gone, I will go across this. But I want to show you this picture here, because this is really close to the Napier grass. This is grass from Germany. It's a different species, but we have the same problems as you have with the Napier here in India. A lot of fibers, very dry, and this is binding a lot of water. And with our technology, we help this customer that he can use much more grass than he could before. So now I'm out. So I go back to this picture. So this customer has always the problem that he wants to feed more grass, and it was not able to feed 100% of grass because he get a problem with the viscosity, the picture you have seen in before. And after installation of our technology, he was able to increase the gas input. You see this in the graphs. The green is the grass, and it is more than double of the grass which he can feed, and that brings him 20% less of cost, and all because of the disintegration and the lower viscosity. And this is very equal. This problem is very equal to the Napier, and I think our ultrasound technology is a good solution. If you have a good feeding, a good mixing, we heard it before, you need a good mixing. This is very necessary, a good cutting in the input, and then a good disintegration that you get the viscosity problem solved. And then you bring your biogas plant with Napier to run. Yeah. So you heard in a short time, you have many benefits if you use ultrasound technology. And we can discuss later in more detail, and we have this discussion later. And then thank you for your time. I think I was okay in time.
Okay, thanks, Antik. Thanks for the wonderful presentation there. So this ultrasonic technique is something very interesting, means which has picked up quite a bit in the Western parts, still to kind of pick up in the Indian scenario. So maybe something that you can also highlight upon is what are the prerequisites that you need for the feedstock or the substrate. Means I saw a diagram in which you showcase that from the digester, you pull out a stream and do the ultrasonic treatment. But any characterization or the prerequisites in terms of feedstock, you consistently mentioned about the Napier grass, application of this in the Napier grass. So if you can just throw some light on what kind of prerequisites in feedstock is needed to kind of adopt this technology, that will be really insightful.
So yes, we can treat every substrate which is pumpable, but it is our technology is very interesting at substrate which are difficult to treat as Napier grass. But every organic material which is pumpable can be treated, and we get an increase in the gas output. We tried. We have more than 200 installations now, and we nearly treated every organic substrate you can think about. Yeah. But the focus on the Indian market is for sure this difficult treatable substrates where we need to solve this problem with the viscosity.
Okay, that was really nice. So now moving on to our next panelist, Anant. So Anant, I believe you have got a wider experience in terms of installing a variety of scale of biogas plant. So one of the interesting aspect that the audience might be interested in is with respect to the mid-sized biogas plants, for example. We have been talking a lot about the large-scale CBG technologies, but a lot of the entrepreneurs where the feedstock is limited, they're looking forward to install mid-sized biogas projects and how the technology kind of differs. Of course, we know the household technology are kind of very simplistic, and so far as the waste to energy techniques are concerned, the large-scale ones, they are kind of upper end technologies. But how about the mid-sized biogas technologies? Can you throw some light on that?
Yeah, sure, I can. So basically, when we are talking a medium size of biogas plants, so if you'll see, the mainly these are earlier mainly these are for power generation. Let's say I'm talking about, let's say, 100 cubic, 400 cubic in that size. So when we have started working on that size in that range, so what we did, we have focused on the application side instead of on generation, because already on generation side the technology are enough matured and people are using a different technology, maybe a floating dome, maybe let's say covered with a membranes or something like that, or maybe a fixed dome, or with a metal tank cover. But what we did for medium-sized biogas plant, we have included one more thing like a piped biogas, because we know that for medium size it's very difficult to go for CBG. And in that case, what we did, we have gone for a piped biogas, and where we have distributed the gas into the individual households. So actually, see what happens. I remember I attended one conference in 2013 in IIT Delhi. So in that, there were also presentation on CBG. But as we know that there are still, we need a lot of policies in all these things. So there we heard about this piped biogas. And we really feel that this is one of the thing can be done with medium-sized biogas plants. And fortunately, we have a good technology similar for a natural gas. Let's say, because earlier days, there are also few experience with this pipe biogas. But what happened there, they have not gone for metering, regulating, and it was very difficult. But nowadays, what happens, so over the periods, the meters, regulators for domestic market get evolved. So we have used the similar kind of things for this distribution network. So because of that, what will happen? Every household will get a good quality of flame, good quality of same experience as that of cooking with LPG. And then only it's possible they can use that one. Because if you go for any kind of villages or somewhere else, they are also having a same aspiration as a city person. So they also want same quality. So we have focused on that. We have implemented. I was in that time I was with Gram Urja, and we have implemented one project with EWB, Engineers Without Border, in MP, where the pipeline is around 4 kilometers, more than 120 households, and everyone. There is a regulator. There is a meter, and very good tariff structures they have gone for, so that they can take care of operation maintenance. That's one of the things we have did at that.
Okay, thanks. Thanks for sharing your experience there. So next, also we have Dr. GP Goval, CTO, uh, Cube Renewables India. So we will be having a presentation from him.
Yeah, good afternoon to all of you. I'm really thankful to IBA and to our president, Dr. A.R. Shukla, and his team to give me an opportunity to share the dais actually. I'm Dr. G.P. Govil, and I'm associated with right now Cube Renewables India, which is a subsidiary of Cube Renewables UK, and Blue Planet Company Environmental Engineering Singapore has also a stake in it. So the problem is regarding utilization of bioenergy, and specifically paddy straw is a big problem right now, as our member from MNRE was also discussing about the utilization of the paddy straw, because come October, November, and Delhi will be fully choked, and there will be problems with the environment and other things. So for this, here I am here to give the solution for that. Next slide. This Cube Renewables Limited, which is a technology provider, left, yeah, okay. They designed this small-scale, locally embedded biogas energy generating system from organic waste. Then many plants have been installed at Canada, USA, Europe, India. In Hisar, Haryana, we have installed at Chaudhry Charan Singh University, Hisar, we have installed the plant. And then all the system is app-based actually. Means OPEX is very less actually, only CAPEX is required. There is only one person who maintains the plant, and then all the data is being collected, analyzed, corrected then and there, and then it works actually. Coming to basics of it, okay, how to monetize waste rice straw in India. Now here is a plant actually. Is this one also? No. I would like to have. Okay, I'll utilize this. Okay. Right now this is a dry digester. Okay. This is made out of the fabric. It is 1100 GCM fabric, and plant is very simple actually. And this is the box trapezium which you see over here. Yeah, it's not working right now. Okay, I don't know. After this name? No, yeah. Dim. Okay, thank you. So this is the dry digester system, where this trapezium is made out of fabric, and there is a base, and then paddy straw is being stuffed inside, and then it is being covered, and after that the holes you see over here at the top, the sprinklers are put. We call it a irrigation system, but you can call them sprinkler also. So what is being done is that first of all, this digester is being fed with paddy straw, and then layer by layer we put the cow dung, the fresh cow dung, and after that we cover it and then seal it. And this technology has been so that from all around the biogas cannot leak out. And then from the pump, and we are having many sprinklers, so we have to run step by step actually. That is, suppose we put 5 sprinklers at the top. 5 means it makes 25 or 30, and then we are having 6. We are having 1 pump and 6 distribution system, and after 2 hours of running of 1 row, then second row, then third row, and fourth row and fifth row, like that. And then in 24 hours, the leachate which is being formed is being recirculated. So the beneficiary is that you utilize the water at one time only. We don't need the water daily, as in it happens in the wet digestion system, where you have you take your paddy straw, you cut it, chip it, then have some chemical processing, and then further on put to the digester, and there also the churning and other things is the problem. But here, absolutely, you can see over here in this, no, there are not many moving parts, and hence it is good to install it. And it can be installed within 2 days, 2 weeks time it is being installed actually. And one of the most advantage over here is that you can move it also. Moving in the sense is, suppose at one place you are having your paddy straw, you have worked for it, and suppose you want to go to another village and another village and another village, you can keep on moving also. So what I would like to say, it is mobile also, and the only operation is very less over here. And then you can see on the next slide at the top over here, the biogas is around 25 millibar of pressure is being generated, and from there it is being extracted actually. This is the paddy straw which is being stuffed layer by layer, and this is a 150 metric ton. We call it dry cube digester 1000. What does it mean is, the size is 15 meter by 15 meter by 4.5 meter high, makes approximately 1000 actually. And for that we call it 1000. We can have from dry digester 500 to 5000. We can scale it up also, absolutely no problems actually. So once this paddy straw is being fed inside, and cow dung is put layer by layer, and then it is being covered. So this is the one you see over here at the base. The water, the leachate is there, and then it is being circulated right to the top. If you see at the top side over here, you will see some hooks and other things. They are the sprinklers, and by rotation, timing, and optimization aspect, it has been done from that angle. And now you can see we have put the current one because it is operational in Hisar, Chaudhry Chand Singh University. We are having methane content as 50%, and H2S content is only 40 ppm from this paddy straw actually. This is the one, and you can see at the top here the irrigators has been fixed. You can put into the balloon, can be used for the power generation, can be converted to CBG, and can be used for the heating, cooking, and lighting. This is dry cube 1000. 150 tons of has been fed. You can get 20,000 meter cube for biogas, and this is a batch. This is a batch production. Means in a year you have to put 4 times. After 3 months you have to again unload it and then reload it, and it doesn't take much time. It takes around 4 to 5 days just to unload it and reload it. You can have 20,000 meter cube of biogas and 10,000 meter cube of upgraded biomethane, 29,000 kilowatt of electrical power, 70,000 hours of you can have your cooking gas, and the fertilizer you get, it is very good actually. I'll show you. From 226 tons of organic fertilizer you can have it, and with a CSR value of emission, your carbon dioxide equivalent, so much is there. So what I'm saying is, it is easy to install, easy to operate, easy to move, like that. This is being put at the Hisar, okay? The balloon, the biogas digester, the flow meter, and the panel control. Everything is automatically app-based control is there. We monitor temperature, we monitor flow rate, we see how much the percentage of methane is happening, because first one month it takes to come up to that level of 50%, because it's a process of from hydrolysis to methagenic process. There's a time period. So approximately 1 month is there, and rest 2 to 3 months you have the biogas with 50% methane actually. This is a compost. We are having NPK over here. Okay. This is just a 20 ton per day CBG model. How much the rice straw we must have, how much the manure, and how much the methane content we will have. Just a, we are trying to upscale it because we are moving from 500 to 5,000, and for 5,000 also you have to put many units, 1, 2, 3, 4, depending on how much paddy straw you are having and how much ton per day of biomethane you want. This can be used for cooking, heating, electricity, and fuel vehicle. Thank you. Thanks a lot.
Wow, indeed. It was a great presentation, Dr. Govil. So one quick question. I think the participants also would be having a lot of questions with them. One quick question on the paddy straw bale that you showcased.
Yes.
So typically, what would be the shelf life of those bales? Because we have heard a lot of concerns regarding the spontaneous combustion of the paddy bales. So typically, what kind of shelf life you expect of such bales, and what can we do to kind of mitigate the spontaneous combustion concerns?
Yeah, I can understand that because it's a process. Because once you are putting the paddy straw in some warehouse and other thing, and if you are not properly maintaining it, then definitely it will catch fire. Actually, it's a process actually. But what I'm saying is for us as a biogas, because my interest is biogas, so we have to put the paddy straw for a year at some warehouse and take 150 tons, 150 tons like that. So it doesn't, suppose it is in the warehouse, it doesn't deteriorate. It doesn't deteriorate at all actually, because we are concerned about the moisture only. Around 15% moisture is there, we are happy about it.
So your solution is that we should maintain the moisture content,
Exactly.
and that would take care of the spontaneous combustion part.
Exactly. Exactly.
Really thankful. We'll come back to you later. Thanks.
So nice.
So we have amongst
Thanks
us
a
Prantik as well from biomembrane systems. So Prantik, I believe you are dealing with the membrane technology, double balloon membranes. So what is your take on the double membrane scenario right now? I know means double membrane has been the go-to technology, right? So far as the balloon storage is concerned. How is your take on that, and how can we go for indigenous production? Because right now I can see that a lot of the fabrics, in fact, the companies who are there at the exhibition, they're going for the import of the fabrics and doing the necessary assembling over here and then kind of selling it off. So how can we go for indigenous production, and how do you see the future technology of the membrane technology evolving?
Okay, thanks for inviting me. So I have been in this this membrane fabric technology since the last 10 years. So this myomembrane company has been incorporated this year, but this has a history of, this has been a combination of JV of two big companies. One is Search Ferrari, India, um, the fabric that comes from France, and Agastya Invention, which has been the manufacturer of inflatables in the last 10 years. So the problem that we're facing while installing double membrane balloons, that uh, as you said, it's a go-to product and not yet completely evolved. But in India, the problem that we're facing, that the awareness and the technicalities of the membrane technology was not known to the people. So what we did, that when we were installing the balloons, we saw that 80% of our balloons were okay, but 20% were failing. The reason was that not the membrane technology was failing, but the membrane management system, like the pressure relief valves, the ultrasonic sensors, and all those things were, were not up to the mark, because the pressure relief valve and the NRVs are required for the low pressure systems, and which are not readily available in the market. So all the accessories were not available to us. Through this JV, the biomembrane has been formed. We are being backed by a German company known as DBDS. This company has been in this biogas sector in Germany since the last 15 years. So not only the membrane technology we are taking into India, but also the accessories and the membrane management system, which gives a life of the membrane to 15 years. Yes, as you said, we are manufacturing these balloons in India, and the accessories will be manufactured in India, but the technology will be European, because the stress strain analysis of the membrane was not done here. So we will be putting this technology over here, because the stress analysis, the wind load, the rain load, and all sorts of hailstorms, sorry, the storms that are coming to the coastal regions, that should withstand the membrane should withstand those factors. So we are working on that, and we are coming with this technology in a very technical and engineered way, not just welding a fabric and installing it.
Okay, perfect. So I get back to you again,
Sure.
yeah, on this, maybe with a different set of question. Now we have Mr. Praveen Nilekar, right? So he's from the design and development team at Kirloskar Pneumatics. So I believe you will be also presenting something about your technique. Yeah, please.
Yeah, good afternoon to all of you. My name is Praveen Nilekar and I work with Kirloskar Pneumatic Company Limited, Pune. We are the leading suppliers and manufacturers of the gas systems, which includes the large gas systems as well as CNG packages, which also includes the bio CNG and hydraulic booster compressors. So we are going to discuss about my topic, which is nothing but the upscaling the bio CNG production and its monetization by downscaling the gas compression. So it sounds weird, but it's true. And we are going to find out the relevance between these two statements in our coming slides. So this is the content of my presentation. So basically we will be focusing on the need to descale the bio CNG gas compression flow rates, then the various methods and its limitations to descale the compression flow rates, and the KPCL solution to descale the compressor flow rates. So if you see, this is a typical gas generation, biogas generation, and the biogas bio CNG production plant, wherein the biogas is generated into the digester. It is then purified using various methods like PSA and so on, and the purified biogas is then fed to the compressors, which is a bio CNG compressor. So this bio CNG compressor will boost the pressure of the gas to 250 bar, which we call it as a bio CNG, and this bio CNG is uh, then sent to the consumers, and the consumers will accept it with the help of direct fueling or with the help of cascades. Now, the uptime of such kind of plants largely depends on the correct synchronization of the various systems which are involved in the plant. Suppose due to some or maybe due to any issue, the biogas generation into the biodigester reduces drastically below its guaranteed flow rates. Then what will happen? The bio CNG compressor will see a very low flow at its suction, and this bio CNG compressor needs to operate at very low flow rates. If it fails to operate at very low flow rates, then there will not be any compression, and this gas needs to be vented to atmosphere or needs to be flared. So this will lead to the monetization loss because you are not compressing any gas. So every system in the plant needs to be capable to adjust themselves to variations in the operating conditions. So while discussing with one of our clients, we understood it takes around 2 months to ramp up the gas production flow rates. Okay, so during normal operations also, after 2 months, there are chances when the gas generation in the biodigester reduces below its guaranteed flow rate and drastically it reduces below 45 or 50%. So this gas generated with up to 30% flow rate, it is not economical to compress this gas, and this gas needs to be vented to the atmosphere. The gas which is generating with a flow rate of 30% to 45% or let's say 50%. This gas you can compress, that is a economical viable solution for your plant. But in current scenario, the various gas compressor package suppliers, they don't have the capacity uh, to descale the compressors to match the capacity of their compressors to compress the gas which is having flow rate of 30 to 45%. So this comes due to this, it is required to descale the gas, and the need to descaling of the gas flow rates of the compressor arised. So as you know, the reciprocating compressors are generally used for the bio-CNG application. The capability of handling the high flow rates at high pressures, high discharge pressures, and also the handling of the low pressure gas due to its staging ability makes the reciprocating compressor best fit for the bio-CNG application. Though these are the best fit for the bio-CNG application, the reciprocating compressors cannot operate on the partial flow rates. Okay, so due to this constraint, the plant uptime may decreases drastically. So we are addressing this point. So for this, we have to descale the compressor, means we have to reduce the capacity of the compressor. So there are so many methods which are specified in ISO 13631 or 11P, which is used for designing of the reciprocating gas compressor systems. We can utilize those, but there are some limitations also attached to that methods. So we can reduce the speed of the compressor to reduce the flow rate. However, the minimum operating speed of the compressor, it limits the use of this method. So we can recycle the gas from discharge, which is at 250 bar, to suction, let's say it's below 50 bar, 15 bar. But as the pressure of the gas decreases drastically, the temperature also decreases, which is called as a Joule-Thomson effect. So due to this jetty effect, the gas will reach to a temperature of minus 50 degrees Celsius, and it's very difficult to handle this gas at minus 50 degrees Celsius. And also there is a power loss involved with this method. Also there is other method which is called as wall unloading, which is converting the double acting cylinder to the single acting cylinder. But generally for high pressure application like bio-CNG, this needs to be avoided due to the vibration and torsional issues. So we have overcome these limitations, and KPCL has designed one compressor package system which will reduce the capacity of the gas compression to 30%. So we have combined two methods of the of the capacity control, which is a speed reduction method and the recycle method. So in first stage, we could achieve this flow reduction to 65% with the help of the speed reduction of the compressor to its minimum operating speed. In next stage, this is the you can say innovative thing we have done. So we have recycled gas from first stage discharge to the first stage suction. So with this, we have reduced the flow, or we have reduced the capacity of the compressor to 30%. So due to the designing of the robust process and making few innovative changes in our Bayer compressor, we could overcome the effects, or you can say adverse effect of the jetty effect, as well as we have reduced the power which is being you can say lost due to the recycling of the high pressure gas. So with this, I would like to conclude my presentation with these two outcomes. In upset scenario, bio-CNG production is feasible up to 30% of the plant capacity. It will lead to the increase in the plant efficiency and the monetization by around 10 to 15%. And KPCL is now working on further reduction of the compressor turn down to 10%. It will give more flexibility to operate the biogas generation and bio-CNG production. Thank you.
Yeah, thanks, Praveen. So that was really insightful. Means it's quite understandable that the plant won't be running at 100% capacity every time. You need to run at a lower capacity. So that's why this turn down ratio and these things are really important. So nice to know that you're working on that, and any further updates or whatever innovations you have, we would like to stay connected with that, right? So that's really insightful. So we have our final presentation from Roman Mitrofanov. Pardon me if I pronounce that wrong. Yeah. So he's the area sales manager from Suma Road Technique GmbH. So I believe he has a presentation on the agitation techniques. So over to you.
Okay, so thank you very much for inviting me to speak today. So we will speak about mixers and what is the current, I would say, difficulties that we have in the substrates when we're talking about biogas plants in India. So the challenges, as we see, we have difficult materials. So in Germany, we often use like agriculture material, like cattle dung. Here we use materials like paddy straw, Napier grass, or press mud. As the previous talker from Weber Entech, we conclude on that it's very necessary to have a good pre-treatment before you put the material inside of the digester, because that helps the mixer to mix the whole substrate inside of the tank, distribute the temperature, distribute all the fresh material so that you can have a higher gas yield. Then the question would be why, for example, we need to have the mixing inside of the tank. So there are different types of substrates that maybe will float up or settle down. Both options need to be avoided. If we have a lot of floating layers, for example, Napier grass, paddy straw, if you put that into water or into your substrate, it will float up. Then we need mixers to destroy this layer so that the biogas can come through. Other substrates, for example, like pressed mud or chicken litter, this will fall down to the ground and build a sedimentation layer. If you don't mix the bottom parts, your sedimentation layer will grow and grow and grow, and you will lose the volume of your tank. So this is like the main two reasons or the main approach what you need to destroy or to prevent inside of your tanks. And of course, as I mentioned before, you want to distribute nutrition and temperature inside of your tank so that the bacteria can work properly. So we from Suma, we have all kinds of agitators. It depends on what is the substrate that you use, what is the tank that you have, and then we can provide a proper solution for the mixers. So we have here a small overview. As you see, we have submersible mixers, central mixers, and long shaft mixers. I would, in my talk, go more into detail about the submersible and long shaft mixers. The central mixer is a version what we use if the tank diameter to height ratio is 1:1. So if we have a smaller diameter, very tall tanks, then there are benefits to use the central agitators. From our philosophy, and in the other parts we would use submersible long shaft mixers. So as you see, the side mixer is installed through the wall, so motor and the gearbox is outside of the tank. That helps for all the maintenance, what means oil change and things like that. The submersible mixer is installed completely inside the medium and can be adjusted through all the tank height. If we look closer to our design, we have a modular design. That means that every part can be removed and replaced very easily. So you open 2 to 3 screws, remove the propeller, can change the propeller to a new one. Normally after a few years, I mean, this is stainless steel. It works very good, but after years there will be abrasion and the propeller getting smaller, so you need to replace it. And this is through the model design very easy with all of our components. So it takes up to minutes to change different parts. Where you need to check is what type of mixer you use. So then you can see what is necessary to remove the mixer outside of your tank. For example, for a submersible mixer, we have an option where you can install a service unit on site on a balcony or a ceiling, and then you can remove the mixer without opening the membrane, without losing gas, or without emptying the filling level inside of your tank. So it's like maintenance, but the process still works. On the other hand, we have the shaft agitators or the long shaft mixers. As I mentioned before, the oil change and everything can be done outside. Through the hydraulic cylinder, you can adjust the mixer up and downwards. With the swivel plate, you can go left and right. So there you have like a big area of effect, and you can adjust the mixer to that position, what is the most beneficial. Of course, we help to find the design and the best position for the mixers, so you have low energy costs and like the most benefit of the mixing. Therefore, we use CFD analysis. We have our company established in 1956, so we have more than 65 years of experience. We can help you when we receive the data, what is the substrate, how the tank looks like, and then we help you to this create and design which is the most beneficial for your project. In the end, a short overview about our company. So we have more than 140 employees, more than 65 years of experience. All of our technology is developed in Germany. We produce everything in Germany and have installations worldwide, so our export rate is more than 64%. Thank you very much.
Thanks. That was really a short and wonderful presentation. So we are coming to the last leg of this discussion. So maybe I will do a round of questions to all the panelists here. So maybe I will get back to Anant once again. Anant, you shared your experience with respect to the technical diversity associated with the mid-size project. So we would like to also understand what are the community level challenges when you go to install such kind of projects. It cannot be that straightforward, right? So you need to take a lot of social dynamics into equation as well. So based on your experience that you have for almost a decade in setting up such projects, if you can share some insights and some of your experience on those lines.
Yeah, always there is a challenge with the community-based projects. When there is a, if there be, it's not on application side, it's on feed size. As same thing we have discussed in earlier discussion also for big plants. Same thing is applicable for small also. Sometimes what happens if there is a goshala or something where there is a collective feedstock is available, in that case that plants run wells. And if we are talking about the gathering of it may be happen for small, big plants like a CBG plants, we can collect the we can have that kind of system. But for medium and community biogas plants, it's very difficult to set up such kind of system. So in that case, you should have some point where you are already have such a feedstock available collectively. And in such cases, only it's possible to have. Second thing, we need to have proper tariff structures and all these things so that it will take care of that system itself. We don't need any fund again to maintain that and to run that project. So it should be from, it should self-sustainable, it should be. So that kind of things need to be taken care while implementing this project. And nowadays there are very good technologies on digester side, like a tubular and flexible digesters are there. So I don't, so it reduces the efforts while implementing the while implementing the biogas plants. What are the efforts required for medium-sized biogas plants? It is reduced and time also get reduced. So that's a good thing.
Okay, great. Also coming back to Antig, so we heard a wonderful presentation from you as well. So means over here, since we are also looking at the lignocellulosic feedstock, that is one of the area of interest in India, particularly the agro residues, and with the Napier grass also coming as one of the potent feedstock. So, what are the innovations that is happening in the pre-treatment technology as such? Means apart from the ultrasonic technique that you talked about, if you can share some insights on the other pre-treatment techniques which are also catching up. If you can share some insights on those lines.
Sorry, I didn't get the question. Sorry.
You didn't get the question?
I didn't understand the question, sorry.
The question is, what other pre-treatment techniques? So before feeding to the digester, you need to pre-treat the feedstock, right? You need to process it well enough so that the digestion happens, the microbiology happens. So what other pre-treatment techniques are kind of catching up or are becoming the trend that you can kind of adopt upon, apart from the ultrasonic, of course, which you discussed?
Yeah. So maybe I didn't understand the question right, but it is very important from our experience that before you think about a pre-treatment, that you think, especially if you use difficult treatable substrate, that you think about how to harvest your substrate, how you bring it to the biogas plant, that you have it in a good condition and not bring grass like this into the digester, then you get problems everywhere. So that is the first you have to think about, that you have a good treatment before you feed it, that you have good conditions, because what you not do there at the beginning, you have the problems at the end, and then you have maybe long fibers in your steerers, in your pumps every year, and you need to do your swimming layers, your sedimentation, whatever. So this is the first what I would recommend to everybody who want to use Napier grass, especially. Really look at the beginning, that you make it as small as possible. Then you avoid a lot of problems. You still will have some problems with the steering and everything when the fibers are short. And I cannot recommend what treatment is in the beginning the best. This is not my experience. I can recommend that if you have viscosity problems with ultrasound, you can solve these problems, because you can destroy this on cellular level. This is unique with this technique, because you go to millimeter scale on the molecule level. No other technology can do this, because with all the grinders, cutters, whatever, you're always on millimeter level or centimeter level, or not on micrometer scale. And to help that viscosity goes down, that the fibers cannot longer fix the water, you need to change the structure on micrometer scale.
Thanks, Antik. So that was really insightful there. Okay, coming to Prantik. So Prantik, you mentioned about the membrane techniques, right? So one of the things that could also be interesting for the participants is, what's the frequency of periodic maintenance or any upgradation once you set up a membrane in a plant? So what's the kind of maintenance that it kind of attracts, right? And if you can also throw some light on the life cycle cost of a membrane that is installed in a plant as compared to the other solutions that are there in place. Some sort thoughts on that would be really wonderful.
Okay. For the first question that you asked regarding the upgradation of the membrane, yes, we are upgrading our membranes, like suppose in the region of Punjab, and where the winter is very high and you need a, like the temperature is an issue for the digester. So we are producing a fabric with the help of such Ferrari, the low E technology, where they have an aluminized coating inside the fabric, where the heat generated from the digester will not escape through the membrane. So that upgradation we are doing. Second is that we are upgrading ourselves with the accessories, as I said, because we are facing that the some pressure relief valves which are already existing are not suitable for the membrane systems. So those pressure relief valves have been upgraded as per the biogas industry and as per the membrane pressure required. That, like an example, that suppose we require a pressure of 20 mm of water column or 50 mm of water column. What we see in the market is that around 80 to 70 mm of water column pressure relief valves are very good, but lower pressure relief valves are not so much accurate. So we are developing those things in our end. And the last question that you asked about the life cycle, yes, we know that the due to the our fabric has a coating of this UV resistance, H2S, and all that things. But yes, it degrades, and as I said before, it has a life of 15 years. And even though we saw that, suppose we have a steel tank and we have a balloon, as the balloon has this cushion effect, I was seeing in Germany that when there was a hailstorm, and even in Meerut, this time rainy season, we say na that in Hindi it is known as ole ole. That is, yeah, yeah, Ola. So at that time, what was happening? There was a steel structure there, so the steel has a dent, but the balloon was not having anything because it was just popping out, and those things are very advantageous for balloons. And as we said, we are working on the wind load and designing the membrane as per this. So I think our balloon membrane has a life of 15 years. Yes. So that's from my point.
Okay. So definitely some sort of maintenance is definitely required. So that's why the life cycle cost comes into play. Now coming to Roman, you had a wonderful presentation as well on mixing. So just wanted to understand a bit more about the CFD that you implement for customized designing. So what's the importance of that? Because I believe for most of the digesters, no digesters are kind of, means every digester is unique in its own way, right? Although we can define some of the characteristics like viscosity and other rheological properties, but then what emphasis do you play or do you kind of see in doing a CFD analysis, and also particularly with respect to treating or mixing lignocellulosic feedstock, which is one of the interesting feedstock from Indian perspective. What ideas you have with respect to mixing such kind of feedstocks?
The CFD analysis shows like theoretical values, how the movement inside of the tank will be. So we have a lot of knowledge and a lot of data through different materials. So we can look up when we receive all the data from you, what is the substrate, what is the amounts, what is the particle size. Our engineers can work on that and calculate like viscosities that will happen inside of your tank. Theoretically, then the agitators work for 1 or 2 days. So it's a computer calculating the movement inside of the tank. And then we create a visualization on how the movement will look like. Of course, if we receive the data from a laboratory, when you gave us already the viscosity, the result of the CFD analysis will be a lot better. But as we see that when we have, for example, plants here in India, and we receive only the data, what is the input? So we don't always get the data from the laboratory. We get the amounts of Napier grass, for example, the sizes, and then our engineers calculate which viscosity, which shear rate will be inside of the tank. And then we create a visualization to show where, for example, can be dead zones and how we need to adjust the mixing to avoid that, so that we don't have the sedimentation or floating layers.
Perfect. So I think we have almost inputs from everyone. I think maybe we can have one question from Dr. Govil as well. So Dr. Govil, maybe across the various process steps that goes in a biogas plant, so which are the areas do you think that is still in need of certain technology advancement? Like most of the techniques can be understood to have already matured, but nothing is mature as such. We see evolution of technology in every 4 to 5 years time frame. But across the process steps, if I have to segment a biogas plant, pre-treatment, digestion, followed by gas upgradation, fertilizer upgradation. So what are the areas in which you see there is a scope for further technology advancement?
Right now, what we are working is that in this our first cycle, we didn't increase the temperature. What is the room temperature? What is the temperature environmentally available? The biogas production was there. Now we are trying to add some trace elements to that, so that we are working exactly what are the elements to be added and how much to be added to have the higher gas production actually. So we are working for that higher methane content. How we can do that? That is the technology for the paddy straw. We are working on it to increase the methane production.
And if you talk about the trace elements, does it kind of require a certain kind of feedstock, or it is across the feedstocks that you can improve the yield with addition of trace elements?
No, that's very difficult actually. That also one aspect that we are trying to have the DNA test for that one. That also we are planning. But otherwise, when the plant is there, in the plant itself, we add that. Okay, so that from conversion from hydrolysis to acidogenic and methogenic, and in this process, how we can improve upon methane content.
And any specific inputs on the various conditions in which you operate the digester? Like it is said that if you go for a thermophilic digestion, you can have reduced hydraulic retention time as well as you can have improved yield. So, any particular thoughts on adopting thermophilic process
No, not
vis-a-vis
in
the
this one
mesophilic?
actually. It will be mesophilic only, not thermophilic.
Okay.
Actually, because we are having temperature around 38 degrees centigrade, 35 to 38, like that. So we are not thinking at all about thermophilic. And it is a fabric material, so we cannot raise at a higher temperature also. So we are not working on that.
Now, one last question maybe to Kirloskar. So maybe if you can throw some insights with respect to how the compression technology is going to advance from here in onwards. I think it's already a mature technology in so far as biogas or CVG is concerned. How do you see this technology maturing?
Yeah, uh, actually, the success of the bio CNG compression, or you can say the biogas production and its enhancement, largely depends on the biogas compression. Okay, so now the biogas compression is limited up to the, you can say, the biogas compression of the purified biogas, means you have to remove the CO2 and H2S before compressing it. Okay, so we are mainly compressing the purified biogas. So maybe at latter stage we can think of compressing the raw biogas, and then you can have the purification out of it. And I think this would be the next stage uh, in the enhancement of the biogas production. And again, we have to, as I said in my presentation, we have to work on the, you can say, uh, making us capable to do to be the to do the compression based on the variations in the process parameters of the biogas plant. So I think these are two, you can say, points on which we can work and enhance the biogas production.
Great, great, Praveen. So I think that wraps up the round of discussion amongst the panelists. Now I would leave the floor open for any questions from the participants. Okay, so maybe Anant, yeah, Anant wants to explain a little bit. Okay, I will come to the question later, but Anant wants to explain a little bit about what he is up to in the next in 5 minutes. Yeah,
Yeah,
please.
just in two couple of minutes, I will take time because I would like to explain what exactly nowadays we are doing in CBG, because we are most of the people want to know about the CBG. Basically, Sambuya is being collaborated, and we have a collaboration with technology companies from Germany. One is a Bauer, another is a Paul Michel GmbH. Basically, see, we know that every equipment is important in when we are talking about the CPG. So what we realize that if we'll take care of each equipment rightly, so obviously this plant will run well. So fortunately, we found a very good partners for us, like a Bauer, which is a world leader in case of double membrane gas holders. And as we discussed earlier, also see in this case, it's not just about membranes, it's about a total system. And that is also designed for a particular project, means considering the gas generation rate for particular digester, gas withdrawal rate. Otherwise, what will happen, there will be any accidents may be possible because of this if we not design it properly considering the project situation. Let me think about, let's say if you are taking out a gas more from the double membrane, we should supply the same amount of air to the double membrane between these two here. Otherwise, it will go down, and let's say we have some bad luck with us. So obviously, because of this wind or maybe let's say rain, there is a chances of it gets triggered. So we need to take care of all these things. So we are providing as a complete system, not just a membrane. And While designing, we need to understand that it's a air supported structure, and it should be designed for that, not just considering a GSM or particular parameter. Definitely these are important, but we need to take care of project parameters as well. And second, our partner is in agitator. It's a Paul Michel, again a leader in this sector in agitator. We are mainly providing a side entry kind of agitators, which is installed on the wall, and with a big shaft length and big impeller, because with a 1.8 or something kind of diameter size, so that we can it is and it's running at slow speed, so it's a gentle mixing is there inside the digester. So that kind of, yeah, we are
Okay,
doing
thanks,
in
thanks,
that.
Anand.
That's our
So,
fuels.
yeah.
Thank you so much.
So now we are once again open the floor for the question. Maybe, yeah.
Yeah, I have two questions. One to Venbird, basically Antikram, and then second question for Cube. So before that, my name is Manisha, and I come from a retail and e-commerce background with zero knowledge of biogas, but do have a very strong background in agriculture. And I am planning, I mean, I have my own land, which is like more than 500 acres back in part of Maharashtra. And we are planning to set up something with Napier grass. So we started the yield because I want to test what part of land will give me what kind of output. And I was very astonished when you said that Napier grass can have a higher amount of fiber, which can be a problem. So the question here is, what do you do with it? I mean, you have so much waste coming out of Napiers, and why would you even want to go with Napier grass as a raw input for the bio-CNG? I don't know. Am I speaking too fast? I can repeat the question.
So, hello, the question was for me.
Yes.
So did I understand correctly? I have some problem with the, I have some echo, so this is really difficult for me to understand the question. The question was, why should we
go for Napier grass?
Go for Napier if you have so many waste?
Especially when there are so much waste out of it.
That's quite a good question. Maybe I'm the wrong guy to ask this. We try to find a solution if the market asks for using Napier grass and difficult treatable substrates, that we can handle it. But you're right. But you have the same issue if you use rice straw, for example. You have a lot of fibers, and this is waste. And if you bring this into the biogas plant, you have the same issue as you have with the fibers of the Napier grass. But I agree with you. If it is possible to use first the waste, this is, in my opinion, the better way. But maybe there is an advantage in the growing parts that they are always available, and maybe the waste is from time to time not available. You can make a better planning, and if you make a big biogas plant, you need to have the substrate all the time available. And with the growing plants, you know when you get the food and the substrate, and you have the energy all the time available.
Maybe I have a follow-up question. In your country, what do you guys do with the Napier grass that is waste, the fiber that is extra? What do you do with it?
Sorry?
What do you do with the waste?
With the
Napier grass
after
waste?
The digestion? After the
exactly,
digestate, yeah. So the digestate of biogas plants normally is a very good fertilizer, because you have a stabilization by the bacteria. You don't lose that much of the nutrients, because it is more stable than if you use, for example, cow dung. If you bring it directly to the fields, you lose a lot to the atmosphere and to the water, because it's not so stable. When you have it before in the digester, you have a more stable fertilizer. So that is very, very good to use as a fertilizer on the fields for the next
Awesome. Okay.
plant. Yeah.
Thank you. Really appreciate it. And I have a second question to Mr. Goel, if I can. Please.
Yeah, of course. Please go ahead.
Mr. Goel did pass a statement during his presentation that with the Cube technologies, you can see a very little OPEX, but very high CAPEX. What is the ratio of OPEX to CAPEX?
No, I didn't say that the CAPEX is high. CAPEX is quite normal. Vis-a-vis the CTR system, that is a wet digestion system actually. Okay, and because in the wet digest system, you have to shred the paddy straw, then feed it over there, do some chemical treatment to that, and like that. And the plant itself is very costly affair for that. Say 6 crores, something like that. But our plant capex is also small actually, and opex is practically nil, like that.
So what would be the ratio in general for like a 5-ton plant?
That has to be worked out. We can come back to you actually. Because right now at this stage, because we have only worked for the smaller plant over here. So right now it's difficult to reply. But definitely I can come back to you provided we share the
Sure, thank you.
Thank you.
Great. If you have any other questions from any other participant, okay, no more questions. So maybe a couple of insights on the Napier grass part. So that was being asked. So maybe based on our experience, why people are adopting the Napier grass as one of the feedstock, it could be because although there are different other wastes which are available in plethora all across the country, right? But Napier grass is considered to be one of the potent feedstock because then any developer has got control on the supply of the feedstock. Right now, all the feedstock that are there at the disposal, you need to enter into agreement with those parties. If it is being provided by some industry, you have some sacrosanctness of those contracts. But if you are entering into contract with a farmer for agro-residues, maybe it could be challenging, right? 1 year down the line, that prices might go up or that farmer might not be willing to kind of go ahead with you. So that's why the project developers or plant developers, promoters, they are looking forward for Napier grass as one of the viable option in which you have the control on the supply of the feedstock. You can do the farming there itself. But having said that, the land area requirements that is there for a typical 5 TPD project, we have calculated to be around 200 to 250 acres of land required for a 5-ton CBG output project, the Napier grass. Of course, with the productivity increasing of Napier grass, we can reduce that, but still that's a significant land requirement. So that is one of the challenge. And of course, with respect to utilization of the fibrous part of it, means we have been in talks with several farmers who are doing contract farming, who are growing Napier grass. So they say that this circulation of the digestate or the slurry to the for the Napier grass, that is quite effective. So they can almost switch to 100% organic if they are growing Napier grass. And I think Antik was also trying to put forth the same equation. So those were some of the insights. Yeah, we have another question there.
I would like to ask to Anand sir. Sir, you have been involved in the project.
If you can hold your mic a bit closer to your mic, mouth.
Sir, you have been involved in the project. So in India, means very few projects are in the production stage. So sir, which raw material is being used? Means mostly, which is giving highest yield if we compare to all feedstock like MCW, municipal waste and paddy straw and Napier grass. So which is being giving more yield in terms of CBG?
Sorry, but I am not a right person to give this answer because let me clarify again these things. Many times people come to us, we are setting up 3-ton projects and give us a quotation for gas holder, agitators, and all these things. So it's very difficult for equipment supplier. Both are important. EPC contractor are also important, and on the other side, the equipment supplier also important. But both have their own skills and their own what you can say competency in that. Sorry, we don't have any competency in that. Yeah.
Just to answer your question briefly, so Indian Biogas Association has got a mobile app, right? You go to Google Store, you download that app. So we have listed across 250 substrates, right? And you can see the yield, what kind of biogas yield you can expect out of those feedstocks, the common feedstocks that could be in the Indian scenario. So all of them are listed. And you can play around with the various other parameters like the dry matter, organic dry matter. If you have got expertise in that, you can play around with those parameters as well to reflect the kind of yield that comes out of those feedstocks. So I will request you to go to the Google Store and download our app. Yeah?
My question is that hard shell of the substrate can be fine particle can be made from ultrasound. It is possible.
I think that question is directed for Antik.
Can we make what possible with ultrasound?
नहीं, जैसे हार्ड सेल होती है उसके अंदर मतलब हार्ड सेल इन दिस सबस्ट्रेट कैन इट इज ऑल सिंपल सबस्ट्रेट इज फॉर्म्ड इट इज पॉसिबल.
So let me just reframe the question. So what he is saying is the cellular structure of a feedstock, right? You have got the cell walls and you have the lignin, pectin, right? So with the ultrasonic technique, will you be able to impact and kind of break through all of the cellular structure and go to the requisite nutrients for the microavailability?
So that's a good question. We can destroy especially the lignin structure, but lignin is not able to get degraded under anaerobic conditions, so the nature had not given these enzymes. So that is still not possible if you destroy it on micrometer-cellular level. So lignin will never be able to get to gas in a biogas plant. This is not possible under the current natural situation. But what we can see, I like this example of this bottle here, for example, very nice. If you would fill this with honey or sugar water, there is a lot of nutrients inside, but as long as the bacteria cannot destroy the plastics, you can throw it in the biogas plant, you have no energy from it. But in that moment, you make holes there inside, there's a lot of energy, and it's a little bit the same with the lignin. There's lignin structure, which is inside there is cellulose, which can be synthesized to gas, but the bacteria is sitting there and looking, and they cannot do anything because it's inside. And then in the moment you go with ultrasound, they make some holes inside. They can use it, but the lignin will never be able to get to gas.
It will be economical, not.
Yeah, it is economically. We have 200 installations.
So that has to be worked out. So every technology has got its limitation, as he rightly pointed out, that doing an anaerobic digestion on lignin is extremely difficult. Only fungus has got a special kind of enzyme which can decompose lignin, right? So with anaerobic digestion technique, it won't be possible. On the other part of it, means how much efficient that technology would be, well, will it be commercially viable or not? Those needs to be worked out with detailed financial modeling.
Thank you.
Any other questions? I think we had an extended run time of this session because we had the General Assembly as well planned, but then I believe we are already short of time. We are already 5 minutes up from whatever time was scheduled for this session. So I believe it was wonderful, and now I leave it up to Sushmita.
Thank you so much, Mr. Abhijit, for wonderfully conducting the session and also concluding it. We'd like to present a memento to all our panelists on behalf of Informa Market. May I request the moderator of the session to kindly present this memento to all our speakers. We'd like to present a memento to Mr. Antique Grams. Thank you so much, Mr. Antique. We thank Mr. Anand Kaure. Presenting a memento to Mr. Anand Kaware. May we now present a memento to Mr. Prantik Sinha. Our heartfelt gratitude to Dr. G.P. Govil. We also like to present a memento to Mr. Praveen Nilekar. We extend a heartfelt gratitude to Mr. Roman. On behalf of Informa Market, we thank the Indian Biogas Association for a very long-term association and relationship. And on behalf of Informa Market, I'm going to present a memento to Mr. Abhijit Mukherjee, who has been the moderator of the session. Thank you so much.